No, we're not going to play Sudoku. All right. The coordinate grid. That's what we call it now. We used to call it the Cartesian plane, but we don't like naming stuff after people anymore.
Why?
We just don't. The Heimlich maneuver is no longer called the Heimlich maneuver. It's called abdominal thrusts. I really don't know why. Everybody calls it the Heimlich, but it's not officially called the Heimlich maneuver anymore. If you go take first aid, they call it abdominal thrusts. I think it's because they're tired of naming things after old white dudes. Because everything is named after old white dudes, because we live in a European-based culture. Now, what's funny is that Professor Heimlich recently saved a lady using the Heimlich maneuver. He's still alive. He's 96. He's in an old folks home in Ohio. And some lady beside him at the table started choking. And he got up, shuffled over, gave her his maneuver, and saved her life. He's 96. First time he'd ever done it. First time he had ever had to use it to save anybody, even though he invented it.
What do you think the conversation after that was?
Thank you.
Well,
I would like to think is how it started, because that is what I would say to you people if I started choking on my coffee and one of you ran up and saved me. Of course, you can't really choke on liquid.
It can go down a little.
Yes, but that's not choking. That's drowning. Yes. You don't choke on the alcohol, you choke on your vomit after you drink too much alcohol and you fall asleep on your back and you go, and then the vomit goes, and then you die. That's how the singer from AC/DC died. That's how the drummer from Led Zeppelin died.
Whoa.
True story.
is there a wrong pipe or one?
There's one pipe, but there's a valve in it. All right, so the coordinate grid. We have a coordinate grid here. The coordinate grid is made up of two things. It is made up of x's, which run this way, and y's, which run this way. Just like a battleship grid. That's why I spent that whole time a couple of days ago talking about battleship.
I love it.
In math class, whenever you see number, comma, number, usually with brackets around it, that means X, Y. And those numbers live on this grid. Okay? X's, positives are to the right, negatives are to the left. Y's, positives are up, negatives are down. Okay? This point right here is what we call the origin. And that is where we start counting. Okay? It's not an origin story. It is not Bruce Wayne's father getting shot in the alley outside the opera and him becoming Batman. It is not. Well, of course they said it was gang-related because Batman was invented in the 1940s when people went to the opera and people robbed people going to the opera because the opera people were rich. Yes, I know, because they had to make it more modern. Because someone coming back from the opera doesn't work in 2017. So they remake them so it sounds better. That's why Spider-Man was bitten by not a radioactive spider, because when Spider-Man was invented, everyone was scared of radiation. Now everyone's scared of genetic modification. So Spider-Man was bitten by a genetically modified spider. That's why they did it. But really, he wasn't. He was bitten by a radioactive spider. But nobody is scared of radiation anymore. I don't know why. Radiation will still kill you. It's not like, oh, it's 2017, I can just go hang out in a nuclear plant and I'll be okay. All right. Back to math. It's not real.
But it
Could be.
can't.
Okay, so we start counting at the origin. If the origin is where we start counting, then what must the coordinates of the origin be? X, Y. But what numbers would we put there? No. What is the number from which we start counting? 0. So the origin is 0, 0. It does a little. 0, 0. Boink, boink.
I'm good at this.
No, you're not good at distracting. I am choosing to allow myself to be distracted because I know I can get back to business.
No, I mean distracting myself.
Everybody understands this because I spent half a period on Tuesday going over this, right? All of you know that. And I wouldn't want you to lose your lunch, Steve. That would make a terrible mess. Lose your lunch, because losing your lunch is the same as barfing. I barfed in grade 8 English. Yeah, I got sick from the cafeteria. Barfed all over the floor. Girl behind me who I liked, they had to clean it up with chemicals, and the chemicals made her feel sick. So not only did I barf right in front of a girl I liked, the chemicals they used to clean it up made her feel sick. I know, right? No. People barf. It happens. Everybody's barfed.
Then you just never talk to her again.
Of course I talked to her again, because she knew everybody's barfed. Just like everybody farts. When you fart in class, everyone goes, "Oh, you farted!" You're like, "Yeah, so do you." And actually, what really happens is people are like, "Hey, that guy's got strong character. He admitted to farting." That's what really happens. All right,
Somebody test that.
let's move along. On the graph right here, you guys see point A, point B, and point C. I want you to tell me their coordinates right in these boxes. Remember, X goes first, Y goes second. So where do we start counting from? And in what direction do we count first? And then in what direction do we count second? I'll wait a moment while you try and write down 6 numbers that are correct. I'll do a dance. Of course I can go cross-eyed. Can you write math questions down? I know. Remember, all you have to do is be able to count. If you need to use your fingers, you're allowed. I've even kept this grid smaller than 10 so you don't have to take off your shoes. So you can count to 20. Because if you need to count to 20, you only have 10 fingers. So you might need your toes.
How did you count with your toes?
The Mayan or the Incan civilization, you know, the dudes that built the pyramids in South America, they counted to 20 instead of 10 because they didn't wear shoes. So they could see their toes all the time. And this was the symbol for number 20. Hey, this was the symbol for number 20. It's a person. All right, what are the coordinates of point A?
5 and 3.
No. -5 and -4. Why? Because I start counting at 0 and I count X's first. So I had to go over to the A. 1, 2, 3, 4, 5. So there's my negative 5. And then I went down 1, 2, 3, 4 to get to negative 5, negative 4. Sam, do you understand how to do this now?
Yeah.
Great.
I said the wrong one.
So you tell me what B is.
5 and 3.
5 and 3. That's absolutely correct. Good job, Sam. And what is C?
5 and 2.
2 and negative 5. Lovely. 2 and negative 5. Good job, ladies and gentle people. Now, for these, you're going to do the exact same thing, but you're going to reverse it. You're going to put the dots on the graph. Put a D at 3, 0, an E at 2, 4, and an F at 0, negative 3. Go! Who would like to tell me where D goes? TJ. How do I get to the spot where I need to put my D? To the left 3. 1, 2, 3. And then? That's it, because I don't have to go upwards at all. There is D. How many people got D right? I like how some people didn't put their hand up. There we go. Where does E go, Ethan? 2 to the right. Up 4. There's E. Who got E right? No, you guys must have had a great math teacher. And where's F? Kian. Down 3. Who got F right? That's deaf. Okay. Okay, now, you guys are smart kids. Here I have a table, but you will notice that I have put nothing in the top of it. One of those is my independent variable, and one of those is my dependent variable. Which one is independent? Is it n or is it 2n plus 1? It is n, because n is the one you choose, yes? 2n plus 1 depends on what n is, doesn't it? So, where does the independent variable go in this kind of table? On the left or the right? To the right. So that's n, yes? Which means n is the first thing we care about, right? So if n is the first thing we care about, and n is the independent variable, and x is the first number we care about, then what are these values here? X's or y's? X's, because they come first. These over here are the 2n plus 1, and these are the y's. Right? So, this tells us that our independent variable equals x's. We also can call it our input. Yeah? And it's on the x-axis. Our dependent variable is on the y-axis, and that is also our output. correct? Now, this 1 represents an n, there's an n. What's 2 times 1? 2 plus 1, 3. So I input a 1. That 1 is an x, isn't it? So I write 1. I output a 3. That 3 is a y. 1, 3. Once I have an x and a y, what can I do when I come over to the graph?
Go over to the right one.
I go to the right one,
And then
up 3. Hey, this goes 2, 4. Where's 3?
in the middle.
Right in the middle.
In the
2, 5. What is the x? 2. What is the y? 5. So where do I go here? Over 2, up 5. Where's 5? Middle of 4 and 6. What's the next point? 3, 7. What's the next point? 4, 9. What's the next point? 5, 11. Dun, dun, dun.
dun, 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 dun.
Everybody got it?
Yeah.
Easy peasy, isn't it? X's go on the left, Y's go on the right. Input goes on the left, output goes on the right. Independent variable goes on the left, dependent variable goes on the right. Prove it. Graph that.
Just put it down with the
Yep. What is the first point that you are going to have? 0, 2. What's the second point? 1, 5. Third point? 2, 8. Fourth point? 3 and 11. Let's put them on the graph. 0, 2. Dun, dun, dun. 1, 5. Dun, dun, dun. 2, 8. Dun, dun, dun. 3, 11. Dun, dun, dun. Now, there's a new word. Linear relation. What word do you see in there that you know the definition of? Line. What does it mean if something is a line? A straight line, right? Did those make a straight line? Yes, they did. Did I connect the line? Did I? No. But they still made a line. So this is, yes. It's a linear relation. Now, I need to tell you why. Because I didn't actually draw a line, did I?
No, but
So what makes it linear is this. How far did I go that way? 1. How far did I go up? 1. No, I went from 2 to 5. 2 to 5 is 5. I went up 3. How far did I go this way? 1. How far did I go up? I went from 5 to 8. How far did I go up? 3. How far did I go this way? How far did I go up? How far did I go this way? How far did I go up? None on here, but how far would I have gone up? 3. What if I went the other way? How far this way? 1. How far down? 3. That way 1, down 3. That way 1, down 3. And how long will that line go on for? Infinite. In which direction? Both. Infinitely that way, going 1 over every time, and infinitely up, going up how much every time? 3. What if I'm going that way?
1.
That way 1 and down 3. Everybody got it? That's what makes a linear relation. If the x changes in a repeating pattern that causes y to change in a repeating pattern, So, if I went, now, I'm not going to go up and down. If I went this way 1 and this way 1, have I made a linear relation? Yes, between those 2 points, correct? If it is a linear relation, where is the next one going to be? This way 1, and then where? This way 1. Where's the next one going to be? This way 1, and then where? This way 1. Have I made a linear relation?
Yes.
Did I connect the line?
Yeah.
No, there's no line on the floor. What if the next one goes over here 2 and up 1? It's no longer a linear relation. Could I still make a line on the graph? Yes, but it wouldn't be linear, would it?
No.
Why? Because I didn't go 1, 1. This time I went 2, 1. What if now I start going 1 and 1 again? This part would be linear, but would the whole thing be linear? No, because that one step was wrong. Everybody got it? Okay, so remember, you can be a linear relation without actually drawing a line. Okay? And even if you connect the dots, because you've all seen graphs that look like this, yes? Is that a linear relation? No. Cool? All right. Oh, yeah. All right, here we go. We're going to make a graph. A photographer charges $40 for a sitting fee and $20 for every sheet of pictures he sells you. We don't have a chart yet, do we? Okay. If we're going to make a chart, we're going to graph this, I need what? I need 2 variables, don't I? I need an independent and a dependent variable, x and y. Which is which? First, I have to decide what are the 2 things I'm counting. I'm counting cost and pictures, prints. Which one is independent and which one is dependent? Independent is the prints, cost is dependent. Why? Yep. How much you pay depends on how many pictures you want. Everyone understand? So what goes on the left? Pictures or cost? Pictures. What would be a good variable to use for pictures? I'll give you a hint. I already wrote it. N. I need you guys to check the spark plugs. First? Yeah, I guess. Oh, hey, do me a favor, James. Can you check the front left tire and see if it's at the same pressure? I think it's down about 10 pounds.
Yeah, okay, okay.
Front left tire and plugs, please.
Tire plugs, okay. Got it.
Okay. What's going here? Cost. Okay. So what is the lowest amount of pictures I can order? 0. Do I pay?
Yeah.
How much? $40, because the photographer had to set up the camera, set up the lights, do all that stuff, right? Everyone got it? Okay. What's the next amount of pictures I can order? 1. Do I still pay $40? Yeah. Plus how much more? Plus 20. Yeah? What if I order 2? $40 plus 20 times what? 2. Right? What if I order N pictures? $40 plus 20 N. Everybody got it? So let's graph it. 0 on the x-axis is how much on the y-axis? 40. So this, what's the point here? 0, 40. Let's put it on the graph. I already gave you the first dot, which means that's 40. So how much is 1 square worth? 20 bucks. What's the next one? 1. I'm going to go out here 2 squares out and make it 1. What's the point there? 1. No. 40 plus 20. 160. So 160. Where's 60? If that's 40, each square is worth 20 bucks, right? So where's 2? 2 over, 1 up, because that's 280, right? Does this make a line? How far did I go this way? No. I went 2 squares, but how far did I go? 1. And how far up did I go? 20. 1 square, but it's 20 on the graph, right? So this one is going to be 1. This one's going to be 20. Where's the next one going to be? 1 over and 20 up. Everybody picking up what I'm putting down? Yeah?
Yes.
Okay. Linear relations have outputs that graph as a straight line. Now, the question becomes, do I connect those dots? I'm going to erase the red right now. Do I connect these dots? Stephen says no, TJ says yes. Why do you say no, Stephen? What do you mean there are 2? I haven't taught you guys. I'm asking you what you think. Can I connect those dots? TJ, why do you think I can? Okay, so if I connect those dots, and I'm not saying you're right or wrong, how much do I pay right there? How much do I pay right there? 50 bucks, right? Right? Everyone agree? Okay. Except, what's that value? Half.
For half a photo.
Can I order half a photo?
I'm sure you can, but
Well, you can if you get a picture taken with your girlfriend, she dumps you, you cut her out. But you get paid for half a picture? No. Understand? Can I go to Safeway and say, I'm only half thirsty. I'd like to buy half a can of Coke.
I'm sorry.
No, of course you can't buy it. You can only buy whole cans, can't you? So, linear relations have outputs that make a straight line. Did we make a straight line? So it's linear, right? But if we cannot have fractional inputs, if we can't have fractions as inputs, we cannot join the dots. Dots. Okay? This is what we call discrete data. Okay? Everybody cool? So I'm going to give you a couple of examples of this. When I turn on my oven to make cookies, what happens to the temperature in the oven. It rises. What else is passing while the temperature is rising? Time. So those are the two things I'm counting, right? Time and temperature.
Yes.
At 0 time, when I turn on the oven, is there any temperature in the oven? Well, it's as warm as the room, right? 10 minutes later, the oven is at a certain temperature, isn't it? Is that higher or lower than room temperature? Higher. So the oven would look like this. The graph would look like this. At 0 time, my oven is going to be at room temperature. Say it's 20 degrees. 10 minutes later, what temperature is the oven? Higher, right? Let's say it's 100. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Everyone agree? Okay. Now, can I connect those dots? Of course I can. Why? Because there's a temperature for every time, isn't there? Right? The oven doesn't disappear in this time and then reappear here with the higher temperature, does it? Everyone understand? Okay. I'll give you another one. I jump out of an airplane. I jump out of an airplane. At 0 time, where am I?
In the plane.
I'm up in the air, right up here, yes? I'm at 10,000 feet up.
I never want to go skydiving.
What happens as time goes on?
You get heat fall.
Eventually, I hit the ground out here at some time, don't I? Can I connect those dots? Why?
Because it keeps going down and it doesn't.
Because I don't jump out of the plane, disappear, and then reappear here, splat. Do I? No. Does everybody understand this? Okay. Now I'll change it slightly. I'll change it slightly. I'll change it slightly. I get paid twice a month. What are the two things that are getting counted? Time and cash. Which goes on the bottom? What's independent? Time or cash? Time. Because time is passing for you, time is passing for me. But if you don't have a job, you're not getting paid, are you? Okay. So I get paid on the 15th and on the 1st of every month, yes? So when I first start my job on the very first day, do I get paid? Nope. So I got 0 money, 0 time, yes? On the 15th, I get paid, right? Say I get paid $1,000. Everybody cool with that? So on the 15th, I get $1,000, yes? What do I get on the 1st? Another $1,000, which means how much have I been paid in that first month? $2,000. Everyone agree? Do I connect the line?
No.
Why not, TJ?
You don't get paid.
Because I'm not getting paid anywhere between there.
You might get a help.
Understand? There's always money in my account, but I'm only getting paid at those certain times. I'm not getting paid at any other time in the middle there. What if I have another job? Then I might be getting paid in the middle, wouldn't I? Right? But could I put it on the same line? No, unless I'm being paid the exact same pay. Everybody understand? Everybody with me? So this one I wouldn't connect. Okay? All right. Let's get back to where we were. So, you guys can tell how old my notes are by the very next example. Because it talks about a DVD club. Those don't exist anymore. But back in the day, they existed. You would send some money to a company and they would send you DVDs. You would get your first 7 DVDs for like $2. Then you'd have to buy 8 more DVDs in 2 years. Except the DVDs you bought were $30 each, instead of the $20 you could pay for them at Walmart.
DVD club.
Yes. So, I've already made the graph, or the table, what is the points from this table that I would put on the graph? Because the first thing I say is graph the data. If I'm going to graph the data, I need x's and y's, yes? Which of these are x's, which are y's? Left is x, right is y. So what's the first point on the graph? 1, 20. What's the second point on the graph? 2, 25. Third point? 3, 30. Fourth point? 4, 35. So let's put those on the graph. There's no scale on the graph. So who decides what the scale of the graph is? You do. Where do you want to put your 1? Wherever you want. You want to put it 1 square over, Kian? Okay, so that's 1. Do I need to write any more? No, because I've already told you that 1 square is worth 1. So obviously this is 2, this is 3, and so on, yes? Can I use that same scale on cost? Can I make this $1? No, I can't, because the first point is 120. Where would 20 be? Somewhere up here. So can I use the same scale? No. What do I have to make each of these worth? I could make them 5, maybe. Let's check. 5, 10, 25, 30, 35, 40. Oh yeah, I can do 5. Do I need to do any more? No, because once I do that, now here's where it gets tricky. 1 this way is how much up? 5, so I got to be careful, right? The first point is 120. Well, there's 1. Where's 20?
4
Up 5, 10, 15, 20. Everyone agree? Where's the next one? You could have done 10s, of course. Yeah, if you did 10s, then the 5s are going to be in the middle, aren't they? So 2, 25. 2, 25. 3, 30. 4, 35. Is everybody happy with our graph? Okay, next question. Should I join the points? Yes or no? I just gave you 3 examples of when to join points or when not to join points. I shouldn't. Why?
Because you can't buy a part of it.
I can't buy half a DVD.
Unless it's out there.
Can I go to Walmart and say, I'd like half of The Force Awakens because I only liked it up till the battle when they destroyed the temple? Will they sell you that? No.
You can.
So no.
All you have to do is break a disc and sell it to you for double the price again. There you go.
Because you can't buy half a DVD. Easy peasy, right?
Yeah.
Can you buy less than 1 DVD?
Fine.
No. Right? You can't buy 0 DVDs. Okay. Is it linear? Yes or no? Yes. Why? It makes a pattern, doesn't it? 1 that way means I go up how much? 1? Each DVD is worth $1? 1 that way is 5 up. For how long?
For 4 the first.
Until I run out of DVDs, right? Right? It's always 1, 5. Describe the patterns. What's the pattern in words? No. That's not explaining the pattern on the table. That's explaining the graph. I went over 1, up 1. Explain to me the pattern in words of what is happening here. Each DVD costs... No. Right.
Oh,
Each DVD costs $5 more. Everybody got it? What's the first one? Right. After. So go and fix it. After the first one. Somewhere where you can deal with a bleeding nose.
Literally anywhere. Yeah, just don't have one.
All right, now, guys.
Yes.
When TJ said, I go right one, up one, was he describing the pattern or the graph? The graph. Because on the graph, we went over one square, up one square, didn't we? But in reality, it's not 1 and 1. Each DVD is not worth $1. Right? Okay. Now let's see if you can really do this. Graph this data. Where are the X's? Where are the Y's? There's the X's, there's the Y's. So what are the 4 points we're going to put on this graph? 1, 5, 2, 8, 3, 11, and 4, 14, correct? So let's put them on the graph. 1, 5, 2, 8, 3, 11, and 4, 14. Are we happy with our graph? Is it linear? Yes or no? Yes. Why? When I go over 1, how far up do I go? 3. Everyone agrees? So it's linear because when I go up 1 floor, I go up 3 meters in height. Not in high, dummy. In height. Now, do I join the line? Yes or no?
No.
Ian says yes. Steven says no. I'm pausing to see if anybody changes their mind. Of course I connect the line. Why, Kian?
Because in the middle of each there is a floor.
There's floor 1, there's floor 2, right? Here's Spider-Man climbing up. Right? Is he between floors right now? Is he still off the ground? So is there a height? Or does Spider-Man disappear between floor 1 and floor 2?
Disappeared.
He doesn't, does he?
Sometimes he disappears.
So in this one, I do have to connect the line. You can't have half a floor, TJ, but you do have a height at every spot up the building, don't you? Understand? I did it on purpose. It's the reason I chose questions like this. It's also the reason I gave you the example of me falling out of a plane and going splat. Right? I always have a height, don't I?
Yes.
Okay? So, do I join the points? Yes. Why? Because there's always an output. And my output is height. Understand? Everybody cool? Okay. All right, now, we've done 3 real-life examples, right? Right? So now we're going to do something with just math. Because we started with real life to show you how this works, right? Math, what we really use math for is to explain real life. So here I have input and an output, yes? What is that number? What letter does it represent? What is that letter? Where do I find x's to put into this? Where do I get the x's that I can put there? From this list of x's, correct? Yeah. So, y equals 5 minus, what's the x? What's 5 minus negative 2? 7, correct? What's the next one going to be? 6. What's the next one going to be? 5. What's the next one going to be? 4. What's the next one going to be?
2.
And so on and so on and so on. Correct? Everyone agree? Okay. So, graph it. My x's are negative 2. My y's are 7. My x's are negative 1, 6, 0, 5, 1, 4, 2, 3. Put them on the graph. Y'all better?
Yeah.
Good.
Where did you go?
2, 7. Where's the next point? Sorry. Negative 2, 7. Where's the next point? Negative 1, 6. Where's the next point? 0, 5. 1, 4. 2, 3. Now, do I connect the lines? Tells you right here. Yes, because this isn't real life, is it? Can I take any number, and subtract it from 5?
Yes.
Can I do that even if it's a fraction? Yes. So I connect these lines. Because it's not real life. Got it? All I want you to do tonight is the last page.
Okay.
Or the last question. Your whole weekend of homework is that page.
Well, from this class.
From this class. Have a good weekend, Ms. Lloyd.
Class, I can